sort of the new content that we're going to look at today is measurements of energy expenditure. Okay, so this is the title, measurements of energy expenditure. And there are 4 measurements on the specification that I'm going to go through, and obviously you'll see that VO2 max is one of them. Okay, and obviously we've just sort of elaborated and recapped that. Okay, the other 3 are sort of new. The only one that some of you may have had experience, it may have had more than one, but one that some of you may have had some experience is the second one here, lactate sampling. Okay, indirect kilometry you can also do when doing a VO2 max test, but we will look at the pros and cons of indirect kilometry next year. The main basis of Year 12 physiology for these particular measurements of energy expenditure is just knowing what they are and sort of what measurements they produce, really. Oh, sorry, I thought I took the pen marking off. Right, so first one we're going to look at is indirect kilometry. Okay, so I've just got a picture here of a female athlete on a treadmill. Now, you could argue that this could also be a similar image for a VO2 max test. Okay, but what is indirect kilometry? So, indirect kilometry, as it says, that it measures how much carbon dioxide is produced and how much oxygen is consumed at both rest and during aerobic exercise. So this machine here, just get my pen marking back on. So this machine here will be measuring how much CO2 is being produced and how much oxygen is being consumed through the machine. Now, what's the reasoning for doing this? It will enable us to find out the main energy source, and the 2 main energy sources will either be fat or carbohydrate. Obviously, one of the energy sources you could use for the aerobic system is protein, but like I've said previously, it's very rare and unlikely that you would rely on protein as an energy source. If you get to the position of using protein as an energy source, in essence your body's eating itself, because your muscles will be wasting away to try and resynthesize ATP. Now, some of the strengths of this, because you're using sort of up-to-date and state-of-the-art technology, the accuracy is very, very reliable, but also can give you a precise calculation of your VO2, so the volume of oxygen you consume, and also your VO2 max. So that's just briefly what indirect kilometry is. Right, so we move on to the next measurement of energy expenditure, and it's lactate sampling. Now, this is something that you will definitely do in a sort of seminar scenario in a sports-based degree. Depending on the sort of the course that you do, it might be in your first year, it might be in your second year. But when I lectured at university, but I also did this as a student, when athletes were doing fitness tests, well, predominantly a VO2 max test, one of the measures that we collated and collected was lactate sampling. Okay. Now, there's various ways you can do this. Okay, and I've got 2 images here to show you. This machine here will be used in both scenarios, but that is what we call a Lactate Pro. If you know someone who's diabetic, the sort of the science behind it is very, very similar. What you'll do, and it looks like sort of a pen as such, you would load a pen with a needle, and there's 2 buttons. There's one button on the side where you would typically hold a pen, and there's a button at the top. Okay, now the button at the top of the pen, that ejects the needle, and you would never press that button when doing a lactate sample, because basically you would eject the needle through someone's finger. Okay, which is very nice. But what you would generally do is it would just take a little prick with the needle, and you'll see the little blue strip here. There'll be a little bit of blood that goes into the strip. That then goes into the Lactate Pro, and literally within a few seconds you will get a lactate reading in millimoles. Okay. Most sort of lab-based protocols when doing lactate sampling will use fingers. Although, but if you're, say, working with a swimmer like that, or also a cyclist who may have their hands on the bars, you could use the ear. Okay. Now, so notice-wise for lactate sampling. Now, that first bullet point might just sound ridiculous, but that is a key knowledge point. It involves taking a sample of blood to measure the level of lactic acid. You don't really need a lot of blood to get a blood lactate measurement, okay? But the key thing I would also highlight, and this is something that we mentioned when we looked at OBLA, is it's really important that you learn the measuring unit for measuring lactate sampling, and it's millimoles. Right, I would really highlight the bits that I've got in red here, okay? So, why is it useful? Why is lactate sampling useful for athletes? Right, there's two key things. It can be used to monitor whether the performer is training at the correct intensity. Okay, so again, one of the things that we will look at next year is that you can train at a certain percentage of your lactate threshold. Okay, so if the intensity of the exercise is too high for a performer, so if we talk about this swimmer here, let's say she was doing sort of 15 400 metre lengths or something at different stages, and she's doing it at too high a pace, she will fatigue much more quickly. So it's making sure that you train at the correct intensity, but also the second bit I've got in red there is it can help monitor fitness improvement. So again, you wouldn't just do this as a one-off thing. If you were looking at an entire training program to monitor fitness improvements for any athlete, lactate sampling is a good measure for that. Now, the other sort of key thing, and if there was one other word that I would highlight in this final bullet point, and we will look at this sort of term in more depth along with other terms, is this. The major strength of lactate sampling is it provides an objective measure. You cannot lie about your blood lactate reading. Now, something that you'll also look at with me next year, but also you will definitely see these in laboratories, and some of you might be aware of these anyway, but there is something in the sports science world known as the Borg scale. And the Borg scale is a rating of perceived exertion, or what it is known as short is RPE scale. Okay. Now, most sports science laboratories will literally have a poster, and it might range from 1 to 10 or 7 to 20, but basically at each number there will be a word associated with how hard you are finding the exercise. So the ones that I used to use would range from 6 to 20. Why it starts at 6, I had no idea, but it was 6 to 20. 6 would correspond to very, very light, whereas 20 would be very, very hard. And at different stages during a fitness test, or VO2 max test, whatever, you would get the subject who was doing the test to shout out a number on how hard they were finding the activity. Now, just by calling out a number, that would be a very subjective measure, because it's the athlete's opinion of how hard they're finding it. And one of the things I used to sort of see was that students might lie about it, so they didn't really want to admit that the early stages of the fitness test might be quite hard, particularly if there was a group of people sort of testing them. Lactate sampling takes all that subjectiveness out of it. Okay, you cannot lie about your blood lactate measure. So if you're saying that you're finding the exercise fairly straightforward, but you've already exceeded your OBLA point at 4 millimoles per litre, you are working anaerobically. So the major strength of lactate sampling is it's objective, and also it's a very much a reliable method of establishing the athlete's OBLA. So hopefully you found that useful. Right, the next one we're going to go on to is looking at VO2 max testing. Now, I've actually got 3 images here that are all fitness tests that can calculate your VO2 max value. Top left, everybody's favourite, is the bleep test or multi-stage fitness test. I'd be very surprised if there's any of you watch this who've never done it. If you've never done it, let me know and I can change that when we come back to college. We've also got the Harvard step test, as you can see there with the instructions, but the other one I want to talk about is this one here. And I've got I wouldn't say it's a claim to fame, but you can be the judge of it. Love Island fans might think it's a bit of a claim to fame. This one here is the Cooper 12-minute run, and in essence, as it says there in the middle, it will measure in meters, particularly if you're doing it around an athletics track of 400 meters, it's easy, but it's basically how far can you run in 12 minutes. Now, when I was teaching BTEC sport at my previous college, one of my former students who ended up on Love Island last year decided that she didn't want to run it. She said, "I'm not running it, I'll just walk." And in a way, she did actually have a point. Even though it's called the Cooper 12-minute run, you don't actually have to run. Okay, it's how far you can travel in 12 minutes. Now, all of these will give you a measurement that will calculate a VO2 max. But what all the three of these have in common, we'll just get the pen marking off there. What all these have in common is that they only provide a predicted VO2 max. It doesn't provide you an actual VO2 max. So the bleep test, for example, I remember when I first did the bleep test when I was 11, and I remember doing it at a sports hall as a football training session, and I got to level 13 when I was 11. I probably wouldn't even get to level 11 now, never mind level 13. If I got to double figures on the bleep test, I'd be happy. But what that can do is that it can then give you a calculation of your VO2 max. The world famous Brian Mack website, you would put in your level and shuttle and it would calculate a VO2 max, but it's only a predicted VO2 max. The only true way, and it goes back to the term gold standard that I talked about as a measurement of energy expenditure, is actually doing a VO2 max test, whether it's on a bike or a treadmill. So I'll just really go through these. So what is a VO2 max test? We talked about what VO2 max is, but a key word I would highlight here is this. In fact, I would highlight that bit. It is a progressive test to exhaustion. It is, and another word I'll try and write out if my pen will let me, it is a maximal test. The idea of this test is it is trying to get you to exhaustion. Okay, where you cannot carry on. Okay, so it is a really, really hard test if done properly. As it says there, these tests can only really be done in a lab, but the key thing is, again, it provides valid results because it uses direct gas analysis. So obviously with both of these images here, you've got both athletes hooked up to a gas analyzer, and they'll be monitoring the levels of O2 and CO2 that are being produced and consumed. Okay, and just a little bit more what the gas analysis is looking at. It's measuring the oxygen that's inspired, so the oxygen that you're breathing in, and the concentration of CO2 that you're expiring. And this will be done continuously through the direct gas analysis. When I was a student at university, from 2003 to 2006 doing my undergraduate degree, the gas analysis was literally done with separate gas bags, and what you did was you had to hook up the gas bag to a gas analyzer and literally squeeze all the gas that was in the bag into this gas analyzer, and then it gave you volumes of oxygen and CO2 in the bag. And obviously the more CO2 that was in the bag, the more anaerobic and the harder that the athlete is working. Okay, so that's 3 of the 4 measurements of energy expenditure, and the last one that we're going to look at is something called the respiratory exchange ratio, or the RER. Okay, what's already up there is an equation to calculate it, but so it's the ratio of carbon dioxide produced compared to oxygen used by the body. And again, as we talked about with indirect kilometry, it can estimate the use of fats and carbohydrates used during exercise. And the other thing, and for me, the key bits I would sort of highlight or star are these 2 bits here. Okay, so it estimates your energy source, whether you're predominantly using fats, whether it's a mixture of both or it's predominantly carbohydrate, and also the relationship with the energy source that you're using will then determine whether you are working aerobically, and obviously if you're working aerobically that will be delaying obla, or it will determine whether you're working anaerobically, and obviously if you're working anaerobically that will speed up obla. Now I mentioned this sort of briefly when we looked at factors affecting the rate of lactate accumulation, that there was 2 RER values to learn. Okay, the closer to 1, I would learn it as 1. If your RER value comes out as 1, you are predominantly using carbohydrates. The higher your RER value, the more anaerobically you are working. That's something that's really, really important. And that might be something I would add in my notes. It's not on my slide here. The higher your RER value, the more anaerobically you are working. And the more predominant energy source when you're working anaerobically is carbohydrates. So an RER value of 1 is one of them to learn. The other RER value to learn is 0.7. So the closer it is to 0.7, you are predominantly using fat. Okay, so again, that can be another good measurement to see how hard an athlete is working, looking at their RER value. Right, so what I'm going to go through with you now is this extended response question. Okay, what I would suggest that you do is I'll talk through it, but it might be worth doing a planning grid in your notes and sort of copying. You can copy the word mark scheme word for word if you wish, and but I would certainly sort of write it down as we've done in class, so you can see how the sort of the quality and depth of the work for each assessment objective improves as we go through. Okay, but before we do that, let's deconstruct this question. Okay, so if we use the part of the bus analogy, so let's box command words. So most extended response questions will probably have 1, but some questions may have 2, so you've just got to be wary of that. So looking at this question, we've got 1 command word and it's evaluate. Now, what are we having to evaluate? We are having to evaluate, so we're now underline subject content, measurements of energy expenditure. Right, we've just looked at 4. This question is specifically looking at lactate sampling and the VO2 max test. You do not have to mention about the respiratory exchange ratio in this answer. You don't have to talk about indirect kilometry. Okay? So, we've boxed the command word, we've underlined the subject content, now we find the sport, the S. And in actual fact, there's 2 sports here. There's a 100 metre sprinter and there's a marathon runner. So, if we were looking at a continuum and we were saying, and this was a continuum looking at aerobic and anaerobic, if we were saying that this end of the continuum was anaerobic and this one was aerobic, you'd probably put the 100 metre sprinter at this end and the marathon runner this end. That being said, that would hopefully help you now to try and figure out, and the final key word for me, I'm going to change my colour, is this word here. Useful. So, how useful are lactate sampling and VO2 max tests for a 100 metre sprinter and a marathon runner? Okay, so that is the question. How useful is lactate sampling and the VO2 max test for the 100 metre sprinter and the marathon runner? And that is the question. Now, some of you might now be thinking, oh, well, actually, this one would be more useful for this particular performer because this particular test might be more useful. The thing also, and it's a rhetorical question, could both of these be used by both athletes? Yes, there may be one test that might be more likely to be used by another one and vice versa, but could both a sprinter and a marathon runner do a VO2 max test and lactate sampling? Yes, of course they could. But the likelihood of that happening is less. Right, so what I'm now going to do is go through the mark scheme. Now, so if we look at the AO1, to do that in blue, in essence, it's can you define lactate sampling? What do you know about the process of lactate sampling? So again, if we think back to what we've looked at in the lesson previously, it's measuring the level of lactate in the blood, so it's taking a blood sample. It's usually measured in millimoles. It's taken to calculate obla. And obviously the other thing that we talked about, it's an objective measure, okay? And obviously, if you're sort of trying to calculate an athlete's obla by lactate sampling, it can then be linked to their VO2 max because of a percentage, okay? If we look at VO2 max testing, again, there's that word, progressive test to exhaustion we talked about. It talks about a treadmill or similar mainly what the other similar cardiovascular machines they're referring to there is either a rower or a cycle ergometer. And then after that, for the VO2 max bit, it basically defines what VO2 max is, and then the final bit that we talked about in our notes, it involves the use of gas analysis or direct gas analysis. So for AO1, you can see it's hopefully fairly straightforward. It's just repeating the notes that we talked about earlier in this lesson. Right, so if we look at the AO2 now, and I'll change it to red. Right, so now what we're looking at is the application, okay? So the first thing is what I was saying there. Both athletes, both the 100 metre sprinter and the marathon runner, could do both tests as part of a training program or just as part of testing, okay? So they both could do it. But then we look at each different paragraph, okay? Now the big thing you might be thinking, if we look at the sprinter and we think back to the continuum that I talked about, sprinters, particularly 100 metre sprinters, will be purely anaerobic, okay? And you might be thinking, well, actually, a VO2 max test, that's the gold standard test for measuring aerobic endurance. So for sprinters working anaerobically, what's the point of them doing a VO2 max test? And that's essentially what this bit is referring to here. So the sprinters are unlikely to do either test, but probably more unlikely to do the VO2 max test. Now that's AO2. You'll see when we look at AO3, it gives reasons why it's unlikely that sprinters will do the test. But it says that a sprinter may use lactate sampling in training. So, for example, one of the things that I came up with when this question first came out is, I used to be a sprinter when I was younger and a lot slimmer. Now, if you were training as a sprinter and you were competing, and let's say that you underperformed in a training run or you underperformed in a competition, and you really couldn't put your finger on why you underperformed, you may actually do a blood sample, a lactate sample, to try and rule out whether you'd actually fatigued or whether you hadn't recovered from a hard training session or whatever. So a sprinter could use lactate sampling, but they're unlikely to use either really, but they could. And then if we go on to the marathon runner, as you can see, it says that they're likely to use both, because remember, marathon runners work aerobic, so it talks about they may integrate VO2 max testing and lactate sampling. And like I said in the video earlier, when you do a VO2 max test, lactate sampling generally happens as well, so they both integrate quite well. And obviously for a marathon runner, knowing what their VO2 max, knowing how much oxygen they can take in and utilise in a minute is really useful, because then they can work at a high percentage of their VO2 max, and then they can figure that out, their obla point. Okay, so really the key summaries from this section here is this: both athletes, both the sprinter and marathon runner, could use both tests as part of a training program. But if then we look at each sporting example separately, and this is something that's really important actually, you've got to make sure that in your answer for this question, and we may look at answering this question in future weeks, your answer would have to refer to both sporting examples in it. If you only talk about the sprint all the way through your answer, you haven't fully answered the question because you haven't addressed the marathon runner, and vice versa. If you only talked about the marathon runner and not the sprinter, you're not fully answering the question. So it's really important that you talk about both athletes. So sprinters are unlikely to do both, but they could use lactate sampling in training, as it says there. Marathon runners most likely to use both tests. They can integrate VO2 max test and lactate sampling within their regular training schedule. Right. If we now look at the AO3, and I'll change it to green, this is where the real evaluation, so this is really where the addressing the command word really comes in. And notice you have to evaluate the usefulness. Now, some of my verbal sort of delivery in the previous slide, I was essentially saying AO3, okay? So, if we look here at the sprint, so if we look at this first paragraph here, which I've just started by it, like I mentioned earlier, a sprinter, and if we go back to the continuum that we talked about when we first looked at the question, a sprinter works anaerobically, and they're focused purely on speed. So they want to the objective of the 100 metres is to run the distance as quickly as possible, and whoever runs it the quickest generally wins. The VO2 max test is a test of aerobic endurance, okay, which is irrelevant for a sprinter, and it's irrelevant for a sprinter because they're working anaerobically, okay. But look at the next bit here. The sprinter may decide to evaluate lactate levels, so again at the end of the race like we talked, to analyse the efficiency of the ATP-PC system. A sprinter would predominantly be using the ATP-PC system because, and I go back to the physiology consolidation that you looked at last week, if we look at duration, or just shorthand, and intensity of exercise, the ATP-PC system will be the predominant energy system for exercise that's less than 10 seconds, or 10 seconds maximum I should say, at a very high intensity. Sprinting 100 metres is a very high intense exercise, okay, and therefore the ATP-PC system would be the predominant one, okay. But ultimately, however, so again a good connective here within this paragraph, the use of either test, VO2 max and lactate sampling, has very little impact because it's merely an anaerobic activity. Okay, and then if we look at the marathon runners, it's talking about more likely to use a VO2 max test, but again because it's the aerobic evaluation. Okay, what you'll generally find is they may do what we call, and I'll write this down, and this is something we'll definitely look at training, is what we call a pre-test. Okay, so if you're doing a scientific investigation about the impact of training, for example, you may do a pre-test. Now, in the context of what we're looking at here, the pre-test would be, right, day one, the marathon runner does a VO2 max test, and a value will come out, so that's their pre-test measure. And then, let's say they're doing a 12-week training camp, you may do a VO2 max test every 3 weeks to show progression. Okay, and to help show progression through their training program, so just highlight that, they may therefore be more likely to use lactate sampling because they can establish their obla point, and therefore in training, to try and get the most advantageous benefits, physiological adaptations, things like more mitochondria, stronger respiratory muscles, greater capillary density of muscles, for example, they can work at a higher intensity because they know their VO2 max, they can establish what their obla point is by lactate sampling, and therefore, if I look at the last bit here, a marathon runner could compare their obla point as a percentage of their VO2 max to increase the percentage through training, because they will be training just below their obler point. So they're really trying to extend the working of their cardiovascular system and respiratory system. So ultimately, the marathon runner would benefit from doing both tests. But notice with the AO3, if I just go back to the AO2 for a moment, you'll notice there's very little depth. It's basically saying a sprinter would do this test and how might they use it, and vice versa. Here, you can see there's a great justification of how useful it will be. So a sprinter may not use this test because, but they could use this test because. A marathon runner would be use a VO2 max test because, therefore, and again, a key word that I continuously am missing, I keep banging on about this word, particularly for AO3, and hopefully you'll guess what I'm writing, is this word here. Oh, is impact. Okay then, what is the impact of a marathon runner doing a VO2 max test? What impact can that have on their performance looking forward? What impact will lactate sampling have on a marathon runner if they're doing it? Okay. So that concludes the latest installment of physiology. Hopefully you found this video useful.